So, hello everybody from Singapore. How are you doing? Are you still there? Yes, you are freezing, or is it not so cold today?
It's not so cold.
It's okay. It's what?
It's warm actually.
Okay. Good. So, as I told you last week, I was in Australia, and there it was summer, but it felt like winter compared to Singapore. But we learned many new things also about computer-aided design, and there's a lot of interest in the area of future cities. But today we want to talk about the Future Cities Laboratory Simulation Platform, because the whole semester, if you remember, we talk about simulation, we talk about projects in Singapore. Today I want to show you a bit more concretely what we are doing in the simulation platform. And also, first we wanted to do today the course evaluation, but we have seen now that today we have to really finish on time, so we will do it next time. So please do come next time and be prepared that we can fill out the student evaluation. Let's look at the content. We have the Future Cities Laboratory. This is the first one, of course, then the simulation platform, some work in progress, and looking back and looking ahead if we have time. I want to have some discussion today as well. And I also want to say hello to the guests who are with us. I can see you on the right side from me, Mihaly Soboslai. Welcome to this lecture. So, the overview of the Future Cities Laboratory. For those of you who listened to the last lecture, you remember the motivation that I gave and also the three main principles. So the motivation, you remember, is of course the growth of the world's population and the disparity, the opening disparity between the urban and the rural population. And of course, looking at a country like Australia, you can see that very drastically, because there basically the majority of the population is already moving into cities and the countryside is basically empty. Then also you remember the principle that we looked at for the whole simulation, which is the urban metabolism and understanding the city as a dynamic system. So this is still the same. And also the next slide, which I explained last time, where you have the scales, the small, the medium and the large scale, and then the different stocks and flows. So the whole last lecture was dedicated to stocks and flows of energy, materials, space, people, finances, information, and so on. You maybe remember also some of those images, but not all of them. If you look through these different stocks and flows, there are always people behind it and research modules, and they reach from low exergy with Professor Leipengut to the digital fabrication with Professors Gramazio and Kohler, to the transformation and mining of urban stocks with Professor Hassler, to the urban design strategies and resources by Kees Christianse, to the urban sociology by Professor Christian Schmitt, to territorial organization by Marc Angelil, to landscape ecology by Christoph Giraud, to mobility and transportation planning by Kai Axhausen, and to simulation platform by our chair. So we want to focus on the simulation platform today. And I could basically tell you by now, after 1 year here in Singapore, we could write a book on almost each one of these different modules, all the things that have happened so far. And of course also in the simulation platform, a lot of new discoveries have been made and many things have happened. But let's look at the origin of it, or the main motivation. The main motivation is to model and to discover the stocks and flows of information, to support different urban design and scenario planning by means of digital techniques in order to identify, connect and optimize dynamic processes that occur at different scales and in different domains. And that, what you see on the board, is the simulation platform, and you see the stocks and flows of people, of energy, of water, of material, of capital, of space, and of information interacting with this simulation platform. The principal goal of this effort is to serve as a hub for the current and future efforts towards fully integrated modeling and simulation of urban environments. This was something that I discovered in all places where we are going with our simulation platform, our Future Cities Laboratory, for lectures, for interviews. This is a very looked after and sought after topic these days. So this fully integrated modeling and simulation of urban environments is something that everybody wants, but very few people actually can produce. And one reason why it is so difficult is the research question that we posed ourselves. And the research question is how the future data acquisition, organization, retrieval, interaction, visualization techniques and instruments effectively deal with the ever-increasing volume of urban-related information. This is the research question, and how we can use these techniques to be successfully made available to designers, decision makers, and stakeholders to provide all necessary information of the city for a continuous design and planning process. Again and again, talking to all these people, the city planners in Melbourne, in Sydney, that came on top of the table. The continuity of the planning process is so important, and the problem is that we don't have the data to be transported from one process to the next to the next. One reason for this, of course, is that still today really working city information model is missing, and all the people who are doing research in this area have been going, depending on their age or youth, to different stages of that triangle here. And you can see on the left side you have CAD, which was computer-aided design, very early on, 30, 40, 50 years ago. If you remember the first and second lecture of this semester, you remember the old examples from Sketchpad and so on. And this was the area of CAD. Then later 2D and 3D representations. Then so-called BIMs, the building information models that we use for teaching at this university and at this department where you are in, and which we also use actually for building the new design building, architecture building in the next year. Then the IBIMs, and finally coming to CIM, City Information Model, which doesn't really exist completely as a working model. But you see all these other attempts under this triangle for standardization, for communication between these different models. It's still not working completely. Can I just get a show of hands? Who of you has worked with BIMs already? BIMs, Building Information Model? Just one person. And that is the visitor. Okay. Do you want to say maybe a few words to that as you have worked with it? Is it useful, or where did you apply it so far?
Yes, in Graphisoft, the Hungarian company who produces ArchiCAD, they have a really strong developer group, and they set up a course for our students, and how BIM works, they integrated into a university course. Now
right.
It's experimental, so we don't have the feedback from the industry, but the new generation, those students who are really capable to use all the features of a CAD program, especially we say not CAD but CAAD, because we say that architect informatics, so not the general purpose CAD program, but it's for computer-aided architecture design program. So we make differences always when we explain it, why they should see whether they use a general purpose CAD program or it's specialized for architecture.
Okay. Thank you, very good. So that is one of the companies who's actually teaching that to the students. That's of their interest, of course, because that model that they built in can be used in practice later, so they think. So that's a very practical application in architecture. What we find, however, but there you should really talk to the experts in the architecture department, how easy it is to design using those tools. It is certainly very good if you have a building designed using this technology, then to construct it, to manage it, and to build it. But for design, there are different opinions how difficult it is to do interesting design with these BIM-based modelers. Anyway, this is an aside, but it shows it is necessary to have a description language in which we describe the cities and the objects in the cities, the buildings, the transportation flows, basically all these stocks and flows that I described last time. We need a system, a language, a representation to describe them. And if you remember Chen Zong, who represented her food flow system at the end of last lecture, she had, at the very end of her presentation, she showed how she could combine or try to combine, let's say, city GML with the different flows going on in a city to make it more visible what is happening in the city. So this is the foundation, or this is a goal and a foundation at the same time. And here's what reality means. In the city, when we want to model a city, when we want to get a handle on all these stocks and flows and want to describe them and want to integratively model them, then we have to look at these different things. In the center, you see the simulation platform, and you see the value lab again, and you see the back end, these big machines and computers, and you see the mobile devices that we will have much more in the future to interact with all of these big models that we can do now only in the value lab or directly in your laptop. Then we have on the top, we have the data acquisition. This is how to get data into the system, which is a big problem, but the quality of the data that you get is of very different quality, and therefore it is hard to have a very smooth interaction between the different data that you get, and also to say how important or how reliable they are. In order to get around this, you have data mining. You remember data mining? We had a lecture on this 3-4 weeks ago. Then we have urban simulation. This is what we look into today. We have interactive design, also based on this simulation platform. And we have urban information visualization. All these things we have looked at during the semester, but we'll look at more today. And finally, this urban information modeling, that was exactly this chart that I showed you before. This is an ongoing effort. And finally, the communication to the outside. So let's look at some of the common things that we have in common in all this simulation platform. One of them is the physical appearance, and this is the Value Lab. The Value Lab where you are now, and the Value Lab Asia. And the Value Lab Asia as a physical environment where the Future Cities Lab researchers from different research streams interact, where stakeholders can discuss ideas with designers using the same visual and physical representations, and where communication with planning agencies and the general public takes place. So I cannot wait. This will be only like 5, 6, 7 weeks from now when we move into the new building and we start to build up our Value Lab over there. So with the next class, maybe we can already have this interaction, this direct interaction from Value Lab Asia to Value Lab ETH. And the new applications that we developed for this Value Lab, here you see one. This is the risk or strategy tool that was built by Remo Burkhardt and his group. And they will demonstrate this program afterwards to people from Luzern and to the media. So this is an example how we can use existing and new software and run it at the same time using new computing strategies here and in Zurich, almost at no with no time lag in between. So this work will be based on the experiences made in your Value Lab in Zurich, but include technology advances of the past 2 years. For example, the improved touch overlays. What you find on these tables in front of you and on the wall, these are touch overlays. This is quite a complex technology. And what you find there is the newest what you can have in this field. So the Value Lab Asia will be the physical place for the simulation platform. In the simulation platform now we will have very different applications. For example, we have to look at topography. Topography is important for every single place where we plan a new city or where we have an existing city. And so therefore cartography and GIS is very, very important. Here our specialist is Tao Wang. He's a postdoc, PhD from Wuhan University. And what he has done already for Singapore here, you remember maybe at the beginning of the course I showed you little examples of this. By now he has increased the resolution very greatly, is actually very, very fine topographic models of Singapore, coupled with the places where most likely flooding would occur, and a very, very detailed network of the rivers and the flows of water in Singapore. And you can see the grid is getting very, very fine, and for basically every part of this grid, for every little grid piece, you can now determine in which direction the water will be flowing, where it will be flowing, and how much will be flowing. And this is so important now for the flood control in Singapore, but for the other areas where we are active now, like in Jakarta. And that's where all these stories that I was mentioning before start to play, because in each one of these places where we go with one of these modules or with the simulation platform, we get into very, very tough interaction between reality, computation, data acquisition, and so on. So this is one thing that is running through. This is a service part, geometry, geography. Then, of course, another service part, very important one, is visualization. So you can see all the cars running around in Zurich. This is an excerpt from Zurich in the MatSim simulation that we talked about a while ago. And you can see always the same place in Zurich and the Bellevue where you have these traffic jams. Later, we will look at this same area again, but with a new tool that we developed here. So visualization of mobility and activity simulation of Switzerland on a high-resolution road network is one part, but of course also here in Singapore we want to do the same thing. And this MatSim software, Multi-Agent Transport Simulation Toolkit, is being developed more and more, and this will be one of the core traffic simulators. Then we have the geometric simulation of urban growth. That is done with the interactive geometric simulation and the 4D cities with the software that is called City Engine, that was sold recently to the company that produces it. Procedural was sold recently to Esri. I think I told you the story that now with this sale, this city simulation software is now available worldwide and a great help. So we can very quickly do all these different approaches towards designing a city in a certain geometry. You can see the topography of the city on the left top side, and then you see different growth models of the city from the top left to the bottom right with increased density. What is also new, which we can do on top of this using this software, and this is moving into cloud computing, because now we can visualize all these things in the cloud. We can take the model, send the model to our big computational engines, and then have the display of the result directly on our handheld devices, on tablets, or even on smartphones. And this is the way we want to export this technology into other countries, specifically into Ethiopia. So these four things that I showed, topography and the simulation of the growth and the geometric services, plus the cloud computing. These are the basic methods that we have running through all of the simulation platform. And now, of course, we also want to do it with a purpose, and we want to go for the ideal future city simulation of the ideal cities, or the ideal simulation of cities. And for this we use historical preferences, and for this also we go back to the definition of the tasks of the simulation platform, to provide the initial basic services that I have shown, and then to answer this research question that you saw in yellow before: how the future data acquisition, organization retrieval, interaction can be made useful for design. Now, let's go through the individual pieces that we have already put into place. We see those 5 big circles, which are urban data acquisition, urban information modeling, urban visualization, and then behavior simulation and interaction modeling as the main pieces. By now, each one of these boxes that you see in yellow and in bright yellow, they are young women or young men behind that. They're doing their PhD. One of them you have met already. 2 of them you have met already. You will meet others too. So I want to walk you quickly with examples to each one of these boxes, and then you can imagine a bit more maybe what the simulation platform is doing for Singapore and also for Zurich. Urban data acquisition. Let's look at these 5. Urban data acquisition, and the first one is on the automated generation of reality-based 3D models. This is something that's done by the group of Armin Grün. For this, we need a lot of data, again, but we get this data from satellites, we get them from flyovers, and we get them from driving around in the city and taking this data. I just learned in Sydney and in Melbourne that there's a whole group of people in the city, about 15 people, who walk around the city the whole year taking pictures and also go into the buildings to really measure the buildings, to take pictures of the buildings, so that they guarantee that the city of Melbourne or Sydney has a complex and complete model of the city all year round. There are very few cities in this world who can afford this type of work, but it is necessary for some cities. And if they can afford it, they can make better planning decisions. So this is quite interesting. The second one in urban data acquisition is the vision-based traffic scene analysis that you see here, because we need to know what is going on in the cities, how the cars interact with the houses. So hopefully they don't drive into them, but that when they drive by, normally you have cars, you have these work done from cars driving through the city, looking at the buildings. But here we are also interested in the other way around, that we look at the buildings and see how many cars are driving by, how many people are walking by. And this gives us an indication for how popular the place is. This, coupled with different measurements with sensors, air quality and so on, gives you an indication of the quality of the city and the neighborhood. I think that's really wonderful. I mean, all of you, it looks back. This is quite amazing. At this time in the semester, I really appreciate that so many of you have come. We could almost do our crowdsourcing experiment today, but unfortunately, Dong Yon Chin is sitting next to you, and you have heard about his work already. This is the latest, which is the mobile crowdsourcing, the latest presentation he has been giving, and which we will use for the new brochure for this Future Cities Laboratory. But you heard his lecture, so you know what he's been doing, and this is a very important part of urban data acquisition. And the last one in urban data acquisition is what we call the reverse procedural modeling. This is quite interesting, because here I just talked about these people going through the city taking pictures of the facades. What you typically get is what you see on the top left image. You get facades, and they're they're all falling towards the top, so they have the perspective. And then with this reverse geometric modeling, you can then rectify these facades, and you can go through them piece by piece, and you can even supply styles to these individual facades. You can differentiate between facades, between streets, between building parts, between no buildings, vegetation, and so on. And by doing this, you can start to reconstruct existing cities where pieces are missing, or where you have just a bit of information, and you can then, with the knowledge from the other many pictures you have taken, you can take these images and then regenerate this city. Very famous examples from this group who's doing that, Luc van Gool. They are redesigning those temples, for example, and the front part of the temple, which is missing completely, was completely automatically re-engineered, if you want, from looking at the other parts of the temple. So this is an automatic regeneration of a lost piece of architecture. I think that's quite interesting, and of course you can reverse it and also use this for design. So that concludes this part of urban data acquisition. Any questions to that? Do you have ideas of more urban data acquisition? What is missing? Every time we think about this, we find new ways. For example, sound, urban sound and urban noise and so on could be easily added, but that might be a next step. So that's the acquisition. Now let's look what we do with this data that we then have acquired. We do urban information modeling, and one of the most prominent one is the 4D Singapore, as we call it. This is the dynamic modeling of change in a city over time. This is necessary because some cities grow so fast, like Addis Ababa, like Mumbai, like Cairo, like Tripolis in the future, like many cities in Africa, like cities in Asia, that if you look at the old drawings from last century or last 10 years, they will not let you know enough about the city for city planning. So that's where you need to do the 4D Singapore. This is exactly what the people in Melbourne and Sydney that I was describing before, the ones that go through the city, take measurements, take photos, are doing. They're trying to keep a constant model of the city over time in 4D, time being the fourth dimension. That is the project we are starting right now. Armin Grün, who is the professor doing that, he's coming next week, moving here to Singapore, and then we start to do this work with him. So that is urban information modeling, 4D geometric modeling. The next one you saw last time we showed, this is Chen Zong's work, and here I have put together her type of modeling a bit more precisely. So you see on the left side the urban metabolism, that is our motivation. Then we have the material flow analysis, that was her main part last time that she described. And then the urban information model on the right side, where you see the different granularities of the urban information model from the bottom to the top. Zooming into that, here you see a bit better picture. From industry, traffic network, housing, restaurants, recycling, you see the different overlays of the urban information modeling. So that is the parametric urban information modeling, and whoever controls this part of the modeling, of course, has a huge amount of information and influence. Again, in certain parts of the world, like in partly in Zurich, with the different agencies in Zurich, also in Singapore, and also in Australia, there are attempts to put together all these overlays that you see there, from industry, traffic, housing, restaurant, recycling, and so on, all these different layers of information, and to make them accessible to the public. This is a very difficult task because normally you don't easily get to this data, and each agency who has the data tries to protect it and not to release it to other people who should not have it, or have not paid for it. So that is a difficult task. And in Australia, again, they're trying to build a focus, like a web interface to all these data that are existing in the cities, so that you can look through a window, just look at what you want, and then get the data to your desktop from these different sources that exist. However, it's very unfortunate that each one of the protection layers are different, and you don't get all this data from the people who have it. So it is very difficult to achieve that. But alone the construction of this interface will cost something like 20 million Australian dollars, so quite a heavy amount of money to get to this data and to use them for urban information modeling. A quite challenging attempt also for information modeling is the diachronicity of urban flows. This is what the students of Professor Hoferstadt will try to do here. And this is where we use information and data in an innovative way. And the diachronicity is, if you want, the opposite to the synchronicity. So this is a very, very challenging work that will be done in urban information modeling. We're starting this work in about 1 month. Then going to very technical aspects, which is the improving simulations with measurements, different measurements. This is a group from EPFL, 2 students who are here already, Maria Papadopoulos and her colleague from EPFL, and they study improving the simulation through improved measurements. A typical example, they applied this already to our new so-called bubble zero. You see here, in reality now, a CFD simulation on the bubble zero, which is the container that came from Zurich to Singapore. You see the container sitting on the left side. This is where we test all the equipment we brought from Zurich, like the glasses, the windows, the air conditioning, the heat pumps, the water cooling, and all these things. And of course, also the heat loss to the outside, to the skin of this building. And that's what this CFD analysis is used for. Already done live here in Singapore with real data here in Singapore. There you can also see the program they were using, the simulation program they were using, ANSYS. And there you can see the speed of the wind going by and the kind of pressure that you find on this building and the arrows depicting the wind direction and the velocity. So that is a typical example. The other example is measurement system design, and show the differences between simulation and measurements for thousands of possible simulation models. This is great because with this you can also falsify certain assumptions that we have about simulation and make it more accurate this way. Also, in this area of behavior simulation, we have the agent-based movement of people. You have looked at the pedestrian flows before. I don't know, you can see on the screen how the people are moving in 2D on this. Yes, you can see it on this one as well. And you might be able to see it also on this one. Yes, I think it works. So this is using the massive software, and in that one you have again the fixed geometry, which is the topography that we saw in the first example. So you could imagine this being the surface of Singapore, of Zurich. Actually, this is the surface of Zurich, of the environment of Science City, where we did a simulation on. Or you can have the interaction here between different agents and people and cars as agents. A car should be driving by now. Yes, you can see it. So these cars are programmed as agents in a computing environment. Public transportation is programmed as agents in that, and the people are programmed as agents. And in the next step, then you could do even the buildings as agents, that they could interact with the cars, with the people, with the public transportation. And in the next step that we're trying to do here is that we have a complete agent-based city model for dynamic city management, that you have what they call a cockpit for city management. Okay, so that concludes this part of simulation behavior, and we come to the last part of interactive modeling, which is also related to urban information modeling, always in the simulation platform. Here we have gestural interaction, people interacting with information model. So all of you are very quiet, you do not move your hands right now, but in a future lecture, I'm sure, next year, 2 years from now, you will, I think, use your hands and your legs much more, because you will walk around, you will interact with the things that I'm showing directly on the screen, lying on the table or sitting on the wall, and you will do a lot of gestural interaction. Or the DNA of the flair of urban ensembles. This is a very challenging research in the same area of Ludger-Hofestadt, and also the trans-geometric mapping of urban movements, that we are trying to get new patterns of mapping from these movements. When we looked at the data mining a few weeks ago, the student who's doing that, Wahid, actually is in this area of, as you can see in this presentation, lots of fluid information become suddenly very stable and developing into quite interesting new patterns. And you can detect a lot of this. People like Zaha Hadid and other officers that use this type of information flow to look at are very interested in this work. And last information flows, this is an example that you saw before very briefly, has to do again with the flow of, or the modeling of the flow of transportation using visualization. This is the work of Kai Axhausen, and now also of our people who work on this, visualizing this flow of information. And you can see we went through this whole different parts. Just to remind you again, urban data acquisition, modeling, visualization, and this is the work of these people. At the bottom of this, I don't know if you can read it, it's a bit small maybe, but these are the principal investigators that are working in this field. Armin Grün, as I said, who will be coming, Ludger-Hofestadt, who will be here with his whole crew starting next April. Then Ian Smith from Lausanne, who was already here. Stefan Müller, Arizona, who is here all the time. Luc van Gool, who is doing this work on the interaction, visual interaction, traffic scene interaction. Ian McLaughlin here from Nanyang Technological University. Benny Raphael here from NTU. And Dr. Matthias Schulze, Oberga, and Tao Wang as postdocs here in the simulation platform. So any of these people, if you read their name on these boxes in the top or at the bottom, you know they are here and working on this simulation platform. And they are also working in that same room where you are now. Lukas Dreyer, who has designed this wonderful visualization, which shows us how the simulation platform and the value lab will look like in the future. We looked at this a while ago. You can ask him also directly how he wants that to look like in the future. Let's look at a few tasks that we intend to do for the next years with the simulation platform. Next year, as I said, we will move into the new building. Different simulations are coming up now already for this space. We have an even newer one that we will display next lecture. Next year after this, 2013, massive simulation support for the different future cities modules, and also in Zurich for the NFP 65, which is ongoing here in Schlieren that you see. Then in 2014, the Value Lab Asia will be much more sophisticated already, and we can support the measurements in a city and also the simulation of energy use in a city, like here in Zurich. That was a simulation of the simulation. And finally, in 2015, we have very dedicated and very detailed simulation platform with which you can have simulation of very large-scale areas in a city. Simulation platform, like all the other platforms, are people. So a lot of these people are already here. When you look at them from the left, this is Maria Papanikolaou from Greece originally, came from EPFL. Then Chong Sen, you saw last time, from China. And then the next person from EPFL is at the third from the left. The fourth from the left is from China. The fifth from the left is from Myanmar. The between and in the background is from Germany. Then again from China. Then from Switzerland, from China, and from Switzerland. And by now this group has really grown to these almost 15, 16 people here that you all see on the list. And they will be here for the next 3 to 4 years. So with that, I want to stop on the simulation platform description and give you the opportunity for a few questions if you have. Yes, please go ahead. Can you use the microphone because it's otherwise quite slow? Dongyun, can you give the microphone maybe?
Yeah, it's coming.
Okay, great, thank you.
Works. I find it very interesting how you explain the creation of urban environment agents, and you mentioned traffic and buildings. But I was thinking, is it possible to include like the open space, the landscape, as one of the agents? Or like sometimes like the open space makes up of like 50 to 40% of the whole city, and it contains information of 40% of the whole city, I think. So how could it be possible? I know it's very, very complicated.
I think that's a great question because, of course, landscape making so much of a city, it is clear that you can model actually everything that's going on in landscape and in the living part of the landscape also as agents. The sound quality, unfortunately, when you had the microphone, every sentence was cut in half. So I hope I did answer your question, but the answer is clearly yes. You can model also animals and other parts of landscape, design trees and so on as agents. And as a matter of fact, that's what we're trying to do. At the moment, there is if you want, a competition between those two models. One is the agent-based design and management, and the other one is what we show with the procedural modeling. And in both cases, we can have landscape ecology and animals and so on, if you want, be modeled by these two different models. And we are interested to run these two models against each other to see which one has the better outcome in the end.
Okay, thank you very much.
Yes, and ask if you want to know more. Go on the website, go to Gideon Ashwanten. He's the one working with agents, and you can ask him directly if he has thought about it deeper. Yes, thank you. Another question.
I would like to ask, it's quite conceptual, I think. Would it be maybe possible in the future to build buildings that automatically update the virtual model of the city instead of always, when the city grows, need to go inside and take measurements again in order to update this model?
This is exactly the purpose of this 4D Singapore, doing that with satellites, doing that with drones flying over the city, because this is doing it from the outside. If you really want, if you have intelligent buildings with sensors and all of these things, yes, then eventually you would be able to do exactly that the cities would give feedback to the system that they have changed, sometimes that they have moved, like the containers that they will construct now at Science City. But this will never be complete. So we have to use a combination of feedback from outside, looking at from the outside, and feedback from the inside. Having a black box for each building would be ideal, because that would record all these things and feed it back to the system.
Thank you.
Work on it. Ask the data specialists like Stefan Müller, Arizona, or Matthias Berger here on the Future City Labs. You can ask them directly on that, how that could be done. And Dongyeon Shin, of course, how people do it with the crowdsourcing. You could have a crowdsourcing for buildings doing all this works. Mm-hmm. Okay. One more question.
Could I have, if nobody has any questions, can I ask something about the flows from the last lecture?
Yes, sure.
Can you hear it? How is the place captured in the flows, or the speed of the flow captured within the stock and flow system? Yeah.
The place, you mean the place where somebody is, or the place of a building?
Yeah, if you have some flows that flow, you need to know the speed of the flowing. Then otherwise it tells you nothing, because the speed could be so slow that it doesn't slow, that it doesn't move, or so fast that you don't see it.
That's right. Okay, so if you remember the definition of the stocks and the flows, if you freeze time of anything, then you have a stock. And a space, a typical space, let's take any space, take the space in Siena, in this beautiful space. So that would be a stock. But in this stock, you would have a flow of people going back and forth. However, if you would decide suddenly to reduce the size of the space in Siena and would have the buildings marching into the space, you would increase the density and you would have a flow of space, and the stock of the space would be diminished. So this is the stock and flow of space is probably the most difficult conceptually one to model, but you picked the right one to make a big discussion about, because there the definition is very, very difficult and debatable. But think about it more. Let's discuss it more when we have time to next time maybe to continue this. But this when we had the original proposal for our Future Cities Lab, people were very afraid that the stocks and flows of space wouldn't make sense, until one of the reviewers stepped forward and said, yes, this is probably the most interesting one of these stocks and flows, so let's keep it. So that this is an ongoing debate also within our research project. Okay, good. So I have to stop here. Next time it will be quite practical again from Jan Halac mostly, where we look at the application of this now with the city engine. This was the program that I was referring to many times, and the results from his group. And then the very last lecture, you're invited to look at the presentation of the other students' work in the Value Lab, but we will announce that next time. So thank you very much for your attention. Look forward to see you next time again, and have a wonderful day, sunny day in Zurich. Bye-bye.